All right, you should have already gone over how to do calculations with respect to significant figures. So what I'm going to do is just now a really quick nuts and bolts review of the two different rules. So when you are collecting data in chemistry, very rarely is the data itself the final answer. You usually have to do something with the data, whether that means throwing it into a spreadsheet or through an equation, something that will result in a final answer that is an accumulation some way, somehow of that data. The reason that this is important is because depending on how you are compiling that data, and you might actually be doing a combination of these two things, your final answer, the number of significant figures that you get to keep in your final answer will be dependent on the quality of the data that it comes from. Okay, so we've got two different operations, so two different rules, or two different classes of operations is what I should say. So if we are multiplying and dividing, right? If we are multiplying and dividing data, so numbers or measurements with significant figures, here's the absolute boiled down definition. Your final answer gets to keep the smallest number of sig figs. Okay, so if you have, let's say these two numbers, 21.43, and this is just a really dumb example, times, I'm going to multiply 2.1. Right? Very simply, 21.43 has 4 significant figures, 2.1 has only 2. Throw this into my calculator, and I get 45.003. If I were to stop here, my final answer would have 5 significant figures, which is awesome, except I can't just arbitrarily create a final answer that has more significance than either of the two data pieces that it came from. Okay, you can't take bad data and create better data. All right. 4 really isn't even that bad, but this one only has 2. Right? This is the weak link of this data set. This really imprecise measurement is going to bring down my final answer. So because this number here only has 2 significant figures and it gets factored into the final answer, I only get to keep 2 significant figures. So I get to keep 1, 2. My final answer would just be 45. Okay, so when you are multiplying and dividing, you want to look at the number of significant figures. You're actually counting significant figures like I did here. And then you keep the smallest number of sig figs in your final answer. Everyone really likes this rule because it's easy. In my experience, people learn this rule and then they over apply it. They want to do it for everything. Don't do that. Okay, we have 2 separate rules for a reason. When you're multiplying and dividing, you look at the number of significant figures. When you're adding and subtracting, you look at something entirely different. When you're adding and subtracting measurements with significant figures, your final answer gets to keep the smallest place value the data has in common. Okay, and again, very bare bones definition, but you should have gone through this already. So with multiplying and dividing, you get to count significant figures. With adding and subtracting, we're looking at place value. So a totally different approach. Let's take these two numbers again, but this time let's add them. So 21.43 plus 2.1. Okay, and let me just do the math really fast. Previously, we counted significant figures. We said this one has 4, this one has 2. That's not what we're going to do here. We're never going to count significant figures. Instead, we are going to look at, here's the key phrase, place value. Okay. My calculator answer has a digit in the hundredths place. That's awesome. All right. One of my data pieces has data or precision in the hundredths place, but the other one does not. The smallest place value that these two data points have in common is the tenths place right here. So I get to keep the tenths place. The hundredths place, unfortunately, is just going to round away. So this final answer would be 23.5. Okay, again, we're not counting how many significant figures, we're looking at place value. So place value for adding and subtracting. All right, counting sig figs, number of significant figures for multiplying and dividing, right? The other thing that you need to know before we dive into more examples is how to mathematically combine units. All right, this is something that we will absolutely use for the rest of the year. Okay, and it's probably something you've seen before, but a refresher isn't bad either. So I'm just going to use meters for the vast majority of the time here. So if I have some number of meters plus some other number of meters, right, my final answer, my final unit rather, will still be meters, right? Subtraction as well. Meters minus meters, still meters. Where it gets interesting is when we start multiplying and dividing. If I have meters times meters, right, most everyone's pretty comfortable with this, I get meters squared. Right? If I had meters times another meters, that would be meters cubed. This, for some reason, is where everyone gets lost. Meters divided by meters. And I can't tell you how many people say meters or 0. And then I get sad. Let's think about this mathematically, please. 4 divided by 4. How many times does 4 go into 4? 1 time. Yay. Okay, similarly, x divided by x, still 1. Meters divided by meters. And then I get people after this and this. I still get people that say meters. No, it's not meters. It's 1. Okay, this is a huge concept that is going to follow us through the rest of the year. And in fact, later this week, this is going to come back. Okay, a unit, in fact, I'm going to write it down. I'm going to write it down in red. That's how important it is. A unit divided by itself. In other words, you find it in the numerator and in the denominator. Cancels out. Which means it turns into 1. Not 0. So if it turns into 0, that's going to mess up a whole bunch of things. Right? It turns into 1. Now, what if I have division? Actually, let me go back to multiplication. What if I had something like this? Meters times seconds. All right, if I had meters times seconds, then that's just what it is. These don't cancel. They're nothing. They're 2 different units. I can't combine them. It's just going to be meters times seconds. If I had meters divided by seconds, right? Similar argument. Meters and seconds do not cancel. They are not the same unit. Okay, this would just be meters per second. These 2 here are examples of what we call derived units. And derived units are combo units, combination units of 2 different base units. All right, they don't cancel, but they work in tandem and usually mean something. So meters per second, right, that would be a velocity. That would be a speed. All right, you're probably more familiar with like miles per hour. Hopefully that kind of rings a bell for you. Okay, so knowing these things, knowing or having a review of multiplying, dividing, adding, subtracting, remembering how to combine units, we're going to do some practice problems. Now, what I have done is gone through and already written down exactly what the calculator spits out. Okay, I'm fairly confident in your ability to plug numbers into a calculator, so I took care of that. The calculator, remember, does not know significant figures. You, the chemist, know significant figures. You need to take care of the significant figures and tell the final answer how precise it gets to be. The calculator does not make that decision. You make that decision. I would absolutely write out what the calculator says first and then go back and assess for significant figures. We're going to assess for significant figures. We're also going to look at units. Each of these answers will have a final unit as well. When we are grading these problems, the correct answer with significant figures will be worth 1 point. The associated unit will be worth another point, right? Getting the unit right is basically like a guaranteed point, even if everything else bombs, okay? Get the unit right. Always, always write it down. Okay, so question 1 that we need to ask ourselves is, are we multiplying and dividing, or are we adding and subtracting? This column just happens to be all multiplying and dividing. This column all adding and subtracting. I'm going to bounce back and forth between the 2 to make our brains remember that there is a difference between the two rules so that we don't end up taking one rule and applying them to everything. So in this first one, I am multiplying and dividing. Well, actually just multiplying, but that's the rule I'm going to use. 11.7 has 3 significant figures. 15.02 has 4. Okay. This one, 11.7, that's the weakest link. I get to keep only 3 sig figs. Wish I could keep 4. Heck, I wish I could keep 6, but I can't. I can only keep 3. So 1, 2, 3. 7 will round up. My final answer will be 176. Now for the unit, I've got kilometers times kilometers, right? So just visualize that. If I have kilometers going one way, kilometers going the other way, right? It's going to make an area. That's kilometers squared. There's my answer. All right, rounded with significant figures. Wish I could be that precise, but I can't get this precise an answer with data that isn't also equally precise. Okay, let's go over to adding and subtracting. I'm not worried about the number of sig figs. Remember, I'm worried about place value. So this number is significant all the way to the tenths place. This number here is only significant to the ones place, but this one is also. So I get to keep the ones place, not because of the number of sig figs, but because, again, of place value. So I'm going to keep the ones place. 2 is going to round away. This becomes just 37. And then liters plus liters is just liters. All right, back to multiplying and dividing. 12 has 2 sig figs. 34 also has 2. 9.445 has 4. That's awesome, but it doesn't matter because I only get to keep 2. Life's rough. Okay, I get to keep the 3 and the 8. 5 is going to round up. Do not make this mistake where you go, okay, 3, 9, then everything else goes away. No, don't turn 3,853 into 39. Don't do it. Don't do it. Okay, it rounds, or they round rather, to zeros. So 3,853 rounds to 3,900 or 3,900. Millimeters times millimeters times millimeters. We just described a cube. Millimeters cubed. There's my answer there. Okay, 2 different approaches. Here's the second approach. 55.3 seconds plus 11.799 seconds. I'm looking at place value because I'm adding. Looks like I'm only going to get to keep the tenths place. That's the smallest place value they have in common. So here's my tenths place right here. Wrong color. That's sad. Tenths place. 9 is going to round up. This becomes 67.1. I've got seconds plus seconds. It's just going to be seconds. 67.1 seconds. Side note, you might see seconds expressed as S. You might see it expressed as SEC. Same thing. Just follow whatever you're given for that particular example. Back to multiplying and dividing. 14.05. Awesome. We've got 4 sig figs. I love having 4 sig figs. It means it was a really good measurement. And then over here, oh, sad. We only have 1 sig fig. So now my final answer is really just going to get dragged down by this really pitiful measurement. Okay. So I only get to keep 1 sig fig. There it is. Everything else goes away. That rounds down because it's 0. So this would be 2. Now, here's where this gets interesting. I have meters divided by seconds. Those 2 units are not the same. They do not cancel. So I would keep them both. Meters divided by seconds, just like that. Okay. If you were typing this into a computer, it might look like this: 2 meters and then slash seconds, where the slash is the fraction line. The 2 meters is in the numerator. The seconds is in the denominator. That's exactly what that means. Okay. All right, back to adding and subtracting. In this case, subtracting. This one's significant all the way to the hundreds place, but looks like I'm only going to keep the tenths place right here. So there's my tenths place. 7's going to round up. This becomes 12.2 centimeters minus centimeters is still centimeters. Okay. Dividing. 108 has 3 sig figs. 550, 2. My calculator wanted to give me 5 sig figs. It was super optimistic. I got to be the heavy, though, and tell it we only get to keep 2. Sad day. All right, 6 is going to round up, which is going to make this another 0, which is going to make that a 2. So 0.2, don't stop there. That's only 1 sig fig. We need to keep 2 sig figs, so this becomes a 0. Remember that 0 is significance after a number and after a decimal. Kilograms divided by meters cubed. Nothing cancels there, so I got to keep it all. Kilograms per meter cubed, that's like big old density. That's basically what's being expressed. All right, last one. And then I can go to bed because it's 10:30 at night. Okay, I'm subtracting, so I'm worried about place value. You look at these numbers and you're a chemist and you go, oh my goodness, look at all the sig figs. That's so cool, except you remember this is subtracting. But still, we get to keep quite a bit of information, which is awesome. Both of these numbers are significant in the hundredths place. That's what I get to keep. This guy right here. The 2 is going to round down. So very simply, this is going to be 116.20 kilometers minus kilometers, still